Hi, my name is Abdul Salam Khan, and the motivation behind our project actually came out of a need. Um, Taking out garbage and recycle out could be easily forgotten due to busy schedule, and also it is a very physically demanding task for those with special needs. For another example, personal to me, where I actually got the idea from is that I was having trouble with a lot of my guests forgetting to take it out on time, then leading to a lot of pile up of garbage in some of the rental properties I manage, and creating an extra work for me. So our solution to this project is an automated controllable system that eliminates the physical demands, incorporates the ease so the user can control it, and of course facilitate the efficiency so there's no extra work required. So for this project, I was a system lead for the drive system. As you can see, our GRAD system has a solar panel to charge the battery, and going down we have a trash can body that we purchased to modify and reuse for our GRAD system, and we attached the some of the sensors, including the ultrasonic sensor for object avoidance, and at the bottom we added a swivel wheel which allows it to turn, and we have two IR sensors left and right that allow for path planning. And around the back now we have two wheels. So our GRAD system is a 3-wheel differential drive with two motors in the back, controlled separately. The two motors are 19 RPM with high torque, and these metal housing were added and added to the body to attach the motors, and also we also attached the metal parts to the body so they can spin with the motors. And let's see, we also created a little window here at the bottom for easy access to the electronics and also see the voltage.
Hi, I'm Heba from Group B, and I was the lead engineer for GRAD's communication subsystem. I also worked on the code for the microcontroller. Regarding the communication subsystem, we used the ESP8266 Wi-Fi module in order to allow our project to read information from a real-time database. The information that is read from the database is transmitted over serial communication to our Arduino MCU. The code for the MCU was developed primarily in C, and it implements a line following algorithm that allows our project to follow a black line on a white surface. Safety was a key consideration in our project, and so we've implemented ultrasonic sensors that can detect obstacles up to 2 feet away from its course. If an obstacle is detected to be in range, then GRAD stops in order to avoid any collisions. One difficulty that we have faced is integrating all of our working parts together. It's one thing to have each of our individual parts working individually, but when it comes to integrating all the subsystems, for example, the drive system, the communication subsystem, and the solar system, it has proved to be more challenging than we have expected. However, we were able to overcome this by performing unit testing to ensure that every individual piece is working before combining it into one unit to protect against any bugs in the code or in the hardware.
Hi, my name is Sadia Boria, and I'm a computer engineering major. I was in charge of the mobile application and the database for our GRAD system. The GRAD mobile application was developed in Android Studio, and Java programming language was used. We also used real-time Firebase database and connected to our mobile application. So the GRAD mobile application has a login page where the user enters their credentials, and the mobile application directs them to the welcome page where they have two options: drive to the curb and return to home. So when the user presses the drive to curb button, it signals the trash bin to drive and it takes it to the destination. And when the user presses the return to home button, the trash drives itself back to where it came from. Despite COVID, we were able to communicate and work via Zoom to complete the software for the mobile application, and we used Discord to share screens and do the peer programming. All the members in the group were really motivated and everybody put the efforts in order to make the GRAD system work. Since we do not know until when this pandemic is going to last, the experience we have had working virtually can be applied to industry if any of us decide to work from home.
Hi, I'm Sean Quinlan. I'm the engineer working on all the hardware, including the battery charging and the overall circuitry. We implemented the first PCB. We had problems removing the microcontroller chip, so we implemented a programmable PCB as instructed from feedback from Dr. Wei. And then having trouble with this, programming it, we implemented through-hole vector boards to complete our overall schematic. We also implemented a second PCB for the battery charging. As you can see here, we have a solar panel that is charging our system. And then to check to make sure it's charging, you can flip down a flap on the bottom and you can see that it's charging at the proper voltage of 13.8. It'll be anywhere between 13.8 and 14.1 due to how much sun that the battery's receiving. So that's how the overall charging works and the functionality of the circuitry of the system.
Did you press the button?